welcome back. I hope you had a good spring break. I hope you rested. I mean, you're still resting a little. You're gonna get to sleep in a little late, but we're gonna get a little bit to work. I know it's been a day, and we always forget what happened in the past. So everything we've learned in the past is gonna come back, and it's gonna help you. So today we're gonna be talking about linear and angular velocity. Mostly angular velocity. We'll talk about linear velocity tomorrow. But before I do that, let's recall something. So recall changing degrees to radians. Changing radians to degrees. And evaluating sine and cosines, and or tangents. Okay, so a little warm-up exercise. So let's do number one. So we're going to change 1700 degrees to radians in form of pi. So all I have to do is 1700 times pi over 180. So that equals to 9.44. But we want it as a fraction. And it's going to be 85 pi over 9. So number two is change negative 5.4 radians to degrees. Alright, so all I have to do is just negative. It's the inverse of what we did before. So it's negative 5.4 times 180 over pi. Alright, so this should not give you anything in pi. So if you put this in the calculator, it should give you negative 9.4 degrees. Alright, and lastly, 3, evaluate sine of negative 19 pi over 4. I gotta look at my unit circle. It revolves twice, so and then I'm left with negative 3 pi over 4, which is equal to negative square root of 2 over 2, because sine is y and cosine is x. Alright, so this is just quick. The good thing about this is that if I'm going too fast, you can always go back and check what I've done. You can replay this as many times until you get it. But of course, if you have any questions, please don't hesitate to email me. All right, so next, we're going to be talking about angular displacement. All right, so what is angular displacement? So angular displacement is displacement. It's an object at the edge moves through an angle relative to its starting position. Okay, so for example, determine the angular displacement in radians of 4.5 revolutions. So, one thing we gotta know. Each revolution equals 2 pi. Alright, that's one whole circle. So one whole circle is 2 pi. Alright, 2 pi radians. So for 4.5 revolutions, the number of radians is as follows. So this is all you have to do, boys. This is extremely simple. It's 4.5, right? Because that's what it's asking right here. What is 4.5? So it's going to be 4.5 times 2 pi. All right, so you're going to put this in your calculator, or you can do it online. You can search it. So all you have to do is 4.5 times 2 pi is equal to 9 pi, right? But in this case, I don't need it in terms of pi. All right, I'm going to need a number. So if you put that in the calculator, which equals to about 28.3 radians. Okay, so here's the difference. In this one, I don't need it in terms of pi. I need a full number. All right, so another example. So example. Determine the angular displacement in radians of 8.7 revolutions. So here's the same thing. This is extremely simple. One of the easiest things we've done. All you have to do is 8.7. You get that number that was given. All right. So right here, and then you multiply that by 2 pi. So this is equal to 54.7 radians. Alright, so this first one's pretty simple. Alright, all you're going to need to know is that you're multiplying the revolutions given times 2 pi. Alright, now we're going to look at the next thing we're going to look at is called angular velocity. Angular velocity. Okay, so what is angular velocity? It is the ratio of the change in the central angle to the time required for the change. Usually represented with omega. So omega. Alright, so omega kind of looks like a W. Alright, so this is how it's going to look. It's kind of like a W, but it's more curvy. Alright, so this is the equation that you need to know. So we have omega is equal to theta over time. Alright, where theta is in radians. Alright, so now we're not working with degrees. We've been working with degrees for a while. Alright, but this is going to be important, because then if it's given in degrees, you already know how to convert it to radians. This is not going to work with degrees. This can only work with the radians. Alright, so make sure that if it's something's given in degrees, that you know how to convert it to radians. I promise you, I'm going to put that in the quiz, and I know some of you are going to get it wrong. So just remember, if I give you degrees, you get to make sure to know how to convert it to radians. The equation is up here. All right, remember, if you have degrees, you multiply by pi over 180. All right, so I'm going to go on into an example. So, for example, determine the angular velocity if 7.3 revolutions are completed in 5 seconds. Oh, there's a D in there. So first, convert to radians. So this is what we did just before. Alright, so because they given the revolution, so we need to work with radians. So all I have to do is 7.3 times 2 pi, which is equal to 14.6 pi, which is equal to, let me get my calculator. I have 14.6 pi is equal to 45.86, so 45.87. Alright, so I'm going to write my omega. So my omega is equal to the theta over time. So then we have 45. We have this. And we're going to go up here, down here. So 45.87 divided by 5, right? And that should give me, so don't forget your units. This is very important. So radians over 5 seconds. All right. So this is going to be equal to 9.2 radians per second. All right. You got to be careful to what they're asking. Sometimes they're going to make you convert from radians per second to radians per minute. And I'll show you how to do that. But you got to be able to label your units so you don't get confused. All right. So another example. Here we go. Example. Determine angular velocity of a carousel that makes 2 5/8 revolutions per minute to radians per second. See, this is what I mean. This is where your box of your converting chart is really helpful. So pay close attention. So you have 2 5/8 per minute, and they wanted to convert to radians per second. All right. So this is how we're going to do it. First off, the first thing we're going to do is we're going to convert this mixed fraction, okay, to a decimal. So 2 5/8. All right. So if you put it, so 5/8 is equal to 0.625 plus 2, that equals to 2.65. All right, so 2.625. All right, so then I'm going to use my converter. So I have, this is my 2.625 is my revolutions per minute. So now I'm going to convert this. So I have 2.625. Now, in my conversion chart, my revolution goes to the top because it's revolutions per minute. So I have rev over the min. Okay, and I need it to be radians per second. Okay, so there's 2 conversions that we need to do. So if I want it in seconds, do I want that in the bottom or in the top? Well, per second means that it's going to be in the bottom. All right, so I need to get rid of my minutes. All right, so 1 minute is how many seconds? 60 seconds. All right, so now your minutes cancel out. But now I need to get rid of my revolutions. All right, so 1 revolution is 2 pi radians. Right? So that cancels out my revolutions. So then I'm left with, if you notice, I am left with radians per second. All right, so I'll just plug this in the calculator, and you should be able, if you plug this in, right, it doesn't matter the order because multiplication and division, it doesn't matter the order how you do it because there's no parentheses. So you can do 2.625 divided by 60, right? And then times 2 pi, and it should give you 0.275 radians per second. Okay, so one thing you gotta know is that the top you multiply and in the bottom you divide. All right, so let's see, let's do another one. Example, determine angular velocity if 5.8 revolutions are completed in 9 seconds. So I'm going to have 5.8 times 2 pi, okay, is equal to how many radians? 36.44 radians. Okay, so my equation is radians over time. So in this case, all I have to do is put 36.44 radians per, how many seconds are they asking? 9, right here. So divided by 9 seconds. So it's equal to about 4, oh, not 9, 4, if I'm not mistaken, 36.44 divided by 9, yeah, it's going to be about 4.05 radians per second. Okay, so this is pretty easy. Let's do another last one. So example, a circular serving table in a buffet has a radius of 3 feet. It makes 2.5, there's a point, revolutions per minute. Determine angular velocity in radians per second. Okay, so this is another conversion. So you have 2.5 revolutions per minute. And I want to get rid of how many, 1 minute is how many seconds? So 1 minute over 60 seconds. That cancels out my minutes. And then 1 revolution is 2 pi rads. So then it cancels out. So then I am left with, if I put that in the calculator, with 0.262 rad per second. All right, so that wraps it up for angular velocity and angular displacement. Like I said, we will talk about linear velocity tomorrow. I hope You can understand this. If you don't, you can look back and restart this as many times as you can. And if you have any more questions, please don't hesitate to email me. All right, have a good one.